In this video, we present our research, Prototypical Contrastive Transfer of Learning for Multimodal Language Understanding. Domestic service robots are one of the solutions for the increasing need for everyday assistance in our aging society. However, training such robots is very labor-intensive as it requires the collection of datasets from real-world environments. It's a time-consuming process. Would any of you like to prepare and manage hundreds of physical environments? Certainly, most of you would say no. And would anyone be glad to set up physical objects for every trial, over and over again? Again, the answer is likely no. This labor-intensiveness can limit the scalability of the robot training process. To mitigate this issue, we can utilize domain transfer from simulation to the real world. This is because collecting simulation data is much more cost-effective and scalable than collecting real-world data. In this work, we tackle the task of multimodal language understanding for fetching instructions. Here are some examples of the task. In this task, given an object within a scene, the model is expected to predict whether or not the given object matches the target of a given natural language instruction. In other words, this task is formulated as binary classification for each object in the scene and requires both vision and language understanding. To emphasize, our focus is on performance enhancement through domain transfer. We perform domain transfer from a simulated environment to the real world for this task. In this work, we propose Prototypical Contrastive Transfer Learning, or PCTL. PCTL is a new method for domain transfer. Here is a summary of our contribution. As I mentioned in the previous slide, we introduced domain transfer to the multimodal language understanding task. While there are existing methods to perform domain transfer, such as MCDDA, most of these methods have only been tested on single-modality tasks, such as vision tasks. PCTL performs domain transfer based on contrastive learning. Our design of the loss function is inspired by prototypical contrastive loss proposed in PCL, but we have extended it to address classification problems in two domains. Here is a quick explanation of PCTL. Given multimodal inputs from two domains, PCTL encodes these inputs into feature vectors. PCTL then performs clustering on these vectors to obtain centroids. Finally, PCTL alleviates the domain gap by minimizing the contrastive loss between the feature vectors and the centroids of the clusters in the other domain. Here are the qualitative results. To perform domain transfer, we built a simulation dataset and a real-world dataset. The simulation dataset was built using the Alfred dataset, while the real-world dataset was built from the Reverie dataset. The simulation and real-world datasets contain 30,000 and 10,000 samples, respectively. Consider the example on the right. Given the instruction, go down the stairs to the lower balcony area and turn off the lamp on the dresser and a red bounding box in the center of the image, the model successfully predicts that the given object matches the target of the instruction, the lamp. Here are the quantitative results. Please take a look at the first row. This row shows the baseline condition in which we trained the model only on the real-world dataset. This baseline achieved an accuracy of 73%. Thus, PCTL outperformed this condition by approximately 5 points in accuracy. Furthermore, the second row shows the result of an existing domain transfer method. MCDDA Plus represents a minor fixed version of MCDDA. We adapted MCDDA to our supervised domain transfer setting. This method achieved an accuracy of 74.9%. Therefore, PCTL also outperformed this method by approximately 3 points in accuracy. In summary, we aim to improve multimodal language understanding through domain transfer from simulation to the real world. More specifically, we propose Prototypical Contrastive Transfer Learning, PCTL. PCTL extends the prototypical contrastive loss for classification problems in two domains. It alleviates the domain gap by minimizing the contrastive loss between the two domains. As a result, PCTL outperformed both the condition in which we trained the model solely on the real-world dataset and the existing domain transfer methods. Thank you for watching this video.